So first, let's have the lap winding. Lap winding has two subparts, which is the progressive and the retrogressive lap winding. So suppose this is our stator and it is our rotor, and it is rotating inside. And also we have here the armature, and is put inside, and also it is rotating. So suppose I will cut this armature. So this armature would look like a flat surface. So this would look like this. So for this video, I will have a flat structure of the commutator segments and the armature slots. So for the lap winding, I will do the distributive type of lap winding. So first, let's have the progressive lap winding. So what is progressive lap winding? So it is called progressive lap winding because the direction of the torn is in the right direction or in a clockwise direction. So for example, this one. So the direction, so it is our first turn and our second turn. So we notice that the direction of the coil and is in the right direction or in a clockwise direction. So that one. So this is our progressive lap winding, our first turn, second turn, and our third turn. And now let's have the retrogressive lap winding. So in retrogressive lap winding, the direction of the turn of the coil is in the counterclockwise direction or in the left direction. Suppose I will put the coil here, and then it is retrogressive because the direction of the coil is in the left direction. So this is also our first turn, our second turn, and our third turn. And also for the lap winding, we have a back pitch, front pitch, resultant pitch, and so on. So suppose this is my lap winding. So back pitch is the distance of the starting coil and the end of the coil. So this one, this is our starting coil or the starting of the turn, and this one is the end of the coil or the end of the turn. So the distance from this one up to this one, so will be our back pitch. So to count the slots, so it will be 1, 2, 3. So for our back pitch, we have 3 slots. And for the front pitch is just the distance between the end of the first turn, this one, and the start of the second turn, so this one. So the distance between this one and to this one, because this is the end of the first turn and it is the start of the second turn, so it is 2 slots, 1, 2. And for the resultant pitch is just the distance between the starting side of the two coils. So this one, because this is our starting coil. So the starting coil of our first turn and the starting coil for the second turn. So the resultant pitch is we will just get the difference between the slots of the two. So 2 minus 1, so we have 1 slot. And for the wave winding, so we will just form a wave. We'll just form a wave for the wave winding. So our wave winding will look like this. And now let's have the wave winding. So wave winding has two subparts, which is the progressive and the retrogressive wave winding. So for wave winding, I have here so this is the rotor and has the eight slots, numbers 1 to 8. And this one is our commutator segment and has a segments of 1 to 8. And this is our shaft. So first, let's have the progressive wave winding. So for the progressive wave winding, so the direction of the turn of the coil will be in a clockwise direction, so or will follow the right direction. So for example, I will enter at 1, and then for the next turn of the coil, I will enter at this either this number 2, 3, or the 4. So for this progressive wayfinding, I have a coil pitch of 3. So for the progressive wayfinding, so if I will enter at 1, so for the next turn, I will add 3 from 1 so that I will know where to enter next. So 1 plus 3 is 4, so I will enter next at 4. So first, I will enter at 1, and I will enter at slot 1, and then end at segment 1. So for the rotor, it is I named it slots, and for the commutator it is segment. So, and I will enter also at segment number 4 because 1 plus 3 is 4. And also I will enter again at number 7, Z at 7, and enter again at 2, and enter again at 5. 2 plus 3 is 5. And then enter again at 8. And then enter at slot number 3. And enter again at segment number 6. And exit at slot number 6. And then go back to slot number 1. So this is the progressive wave winding. So it will look like this. So it is progressive because I start from 1, and then the next turn, and then I enter again at next slot number 4, and then I follow the right direction or the clockwise direction. And now let's have the retrogressive wave winding. So for retrogressive wave winding, so we will follow the counterclockwise direction or the left direction. So for example, if I will enter at slot number 1, so for my next enter of the slot, so it will be at number 8 or number 7 or either number 6. So in the progressive wave winding, I have the coil pitch of 3. So and the process, I add 3 for me to know which slot would I enter next. So in the retrogressive, I will minus 3. So 1 minus 3, so for example, 1 minus 3 is equal to 6. And then if I enter at slot number 1, and then for the next turn, I will enter at slot number 6. So let's have the retrogressive wave winding. So first, I will enter at slot number 1. And will also exit at segment number 1, and will enter again at segment number 6, and also enter again at slot number 3. And enter again at segment number 8. And then enter again at slot number 5. enter again at segment number 2, and enter at slot number 7, and enter at segment number 4, and also slot number 4, and then go back to slot number 1. So this is our retrogressive waved winding. So this is how it looks like for my demonstration. It is retrogressive wave winding because it follows the counterclockwise direction. I first enter at slot number, the coil first enter at the slot number 1, and then second enter at the slot number 6, and then 4, and then 2, and then 7, and then go back to, then 4, and then go back to 1.